Okay, I'm going to show you the world's easiest, cheapest 1 minute flat earth test. It's a simple test. You don't need a laser, you don't need a theodolite, you don't need a high altitude balloon, you don't need a GoPro camera, you don't need a rocket, you don't need any of those things. All you need is a few simple things. First of all, you need yourself to find yourself a flat earther, like one that you can actually talk to in person. I've never met one of those. It makes me wonder how big of a movement this really is. But anyway, but you need a flat earther that has a concrete idea of the model that they support, like some kind of map with a little bit of idea of sizes of things. Because a lot of flat earthers lately have taken to the idea that they don't have to state any affirmative position. Like they don't have to say anything about what they think is really happening. Mostly what they say is, well, we don't really know what the sun is, and we don't really know how big the earth is, and we don't really know how far apart the continents are. We don't have a true measurement of the, right? They all could be lying to us. They're like, they've got this whole thing of like never saying anything affirmative. And that way they think that, like, because I never said anything affirmative, I don't have to defend anything. And if I don't have to defend anything, then I can't be proven wrong. It's a pretty slick, they think it's a slick rhetorical trick, but pretty transparent. But so you need to find somebody who's actually going to make some kind of affirmative assertion. Like, this is what I think is happening. And then if you find somebody like that, then all you have to do is sit them down with these three things: a piece of paper, a ruler, and a pencil. So here's what you do. Give them a piece of paper and the pencil, and then say, okay, think about your map, and imagine that you've got somebody on the earth somewhere who is seeing the sunset. Like somewhere off in the distance, the sun is about to disappear from view from that where that person is standing. And then at the same time, the same moment, another person is standing far away and is experiencing noon, where the sun is straight overhead, like exactly straight above them. Not just 12 o'clock local time, but I'm talking about where the sun is perfectly overhead. Like maybe they live near the equator at a time of year when the sun hits exactly straight up 90 degrees in all directions. Okay, so once you like get them to think about that, then try to think how far apart are those two places. How many, you can think miles or kilometers, it doesn't matter, whatever your person prefers. And say, okay, so they think of a number, and then what you want to do is have them draw a horizontal line across the paper, and from wherever the sunset is to seeing the perfect 90-degree noon, wherever the noon, so you have two locations. And then you make it a scale: 1 inch equals 1,000 miles. You can make 1 centimeter equals 1,000 kilometers. It doesn't matter, something like that. So you just draw the line, right? Get out a ruler, draw the line. There's a pencil, draw the line, and it should be, try to be fairly accurate. Encourage them to be fairly accurate. Like if they say it's 7,000 miles, and they make a 7-inch line, or 14,000 kilometers and make a 14-centimeter line, whatever it is. And then let them use their numbers. It's fine. You don't have to argue with them about where they get the numbers or anything. Just say, use your numbers. Okay, and then from the right over there, these people who are looking straight up at the sun. How far away is the sun? How high is it straight up in the air? And again, use the same scale. 1 inch is 1,000 miles, or 1 centimeter is 1,000 kilometers, whatever you like, or whatever that person likes, and then draw the line straight up. Okay, so it's important that the scale of both lines is the same, because if you don't use the same scale, it'll mess things up. So once this is drawn, then say, all right, let's draw a third line that goes from the sunset people over to the sun, like this, and it makes a hypotenuse of a right triangle like that. Okay, so we're going to draw a third line up like this, and then have them look at that for a second, and then point out that that angle right there, the angle between the flat ground and where they're looking up at the sun, to the altitude of the sun that they decided was the altitude, that would be the angle above the horizon that the sun would appear at the time that the sun sets. And you say, wait a minute, the sun sets when it dips below the horizon, but they just told you the sunset would be that far away, the altitude would be that high, that would have to be the angle. Now maybe there's a degree or two of refraction or something that you could let them have, but that wouldn't it's hard for them to make this without making it a pretty significant angle. So a couple of degrees, you can let them have it one way or another, it won't matter. So at this point, the person is probably going to be confused. Okay? They are going to be wondering, what the heck? How can I make this work? So one possibility is they could say, well, I'll make the distance further. But that doesn't really solve the problem because it still makes an angle. It's a little bit smaller angle, but it doesn't get it all the way down to the horizon. And they starting to have a terrible problem here because they make that very long and they go off the Earth. Like the Earth is, they said the Earth is this many miles across, and if you make it that far, then pretty soon you're going off the Earth. And then that wouldn't make sense. How can you go off the Earth? And you say, well, I know what I can do instead. I'll make the sun lower. Like I'm lower the altitude. Instead of 3,000 miles, I make it 1,000 miles or 500 miles or whatever you want, whatever they can do. But even if they make it lower, right, it doesn't make that angle go away. It just makes it a skinnier angle. And the problem with that, well, hopefully you can make them realize that the only way to get the sun down to the horizon is to make the altitude 0, right? If you really want to get an angle where the sun is right on the horizon, you have to make the sun sitting right on the ground. That's the only way to do it. And that, of course, we never see that, right? The sun, it doesn't make any sense that the sun is on the ground. We always see the sun come down. So either we say that the sun it goes and sits on the ground somewhere, but obviously that never happens because all those people would be burned to death, or the sun sort of fades away somewhere 15 or so degrees above the horizon. That never happens, right? Does the sun ever fade away 15 degrees above the sunset or above the horizon at sunset? No, it never does. The only way to get that sun down to the horizon, to get that angle to 0, is if we live on a rotating globe. Try it with one of your flat earth friends and see what they think.